In this lesson, we mainly focus on force vibration in terms of vibration unbalance. Okay, when you have this shaft over here, when it starts to turn, eventually you will cause the whole system to vibrate. Alright, and then we talk about eccentric mass. You actually move, you know, imagine move off space or whatever. When it move off space, it will cause a little force. Okay. This portion here I don't understand actually, so yeah, just don't listen. Yeah, but nonetheless, we talk about how to derive an equation to describe the amplitude of the vibration itself. Because when you have the amplitude itself, you can actually start to see how we actually reach resonance. Okay, when resonance, the amplitude will actually go increase, right? So eventually we want an equation same as what we have done earlier for the force vibration. And then we sub in certain stuffs, right? And then we assume certain stuff also, and nonetheless saying that f naught is equals to MEW square. So this equation you have to go and memorize. Okay, this will not be given to you. And then what other stuff? And then yeah, this is only one. So if you know this one, you can just straight away sub in into the last week force vibration equation, and you can easily rearrange to derive our this equation over here. Okay, by using some subbing in of natural frequency or beta. So you just sub in here and there, and eventually you get this. And then just to take note that in your datasheet they're talking about z over x. Z over x is actually mx over me, okay, which is the mass of the system, the mass of the whole system, okay, including the shaft, and then the amplitude divided by the mass of the shaft itself, multiplied by eccentric distance, okay, and then here and there. And then nonetheless, we also talk about the tutorial question. Um, Typically, what we want to emphasize on is on knowing the graph itself, pi over 2. By now, I still don't know how we derive this, but it is best if you will go and ask, okay? Because it's talking about when it's moving upwards, the angular position of the eccentric at the instant the structure is the position. When it's moving outward, the eccentric position is different. It's different. I don't know. In terms of angle, I don't know how to describe. Okay, so this is one part I don't understand. You need to really observe the phenomenon, then you can understand. Nonetheless, this is all we have, and then also know that these are all the equations given in the datasheet. You need to know how to sub in, where to sub in, and then if you sub in wrongly, like what I did earlier, if you remember this one over here, I sub in mx and me, you know all these values, and then supposedly I should have the right answer, but then I don't know why I got the wrong answer. This is ridiculous. Anyway, so yeah, so typically you want to use the f naught. Okay. Oh yeah, it's because 2 times, right? Okay, hold on. Okay, never mind. It is still the wrong answer. Never mind. So nonetheless, you need to know which one to pick. Okay, f naught or z over x. Okay. Still the same that we say the f naught. It should be the same because we are using f naught is equals to MEW. I don't know why we cannot get that value, but anyway, so I'll not go into that because you need to know, but nonetheless you need to know, the only formula you need to know is actually the f naught equals to MEW squared, which is this one. And then the other thing you need to know is actually the angular velocity, how to change to radian per second. We're talking about revolution per minute is radian per second. Okay, is the angular velocity is on. Nonetheless, it is the system frequency. Right, the system frequency. And then you also need to know you need to change to mass. So you need to go and practice real hard to do it like flash, just very fast. So these are all the stuffs, and I think the basic concept are there. So yeah, see you in next lesson.